Okay, today we're doing 8-7, solving systems of linear equations. So this is the exact same as when we're just graphing a linear equation. It's just now you're going to graph two or more. And really, only today we'll just deal with two. So, two or more linear equations form a system of equations. Okay, so that just means there's going to be more than one. A solution of a system is any point, and technically it could be more than, it could be a lot of points or just 1 point, which I'll explain in a little bit, or it depends on how many lines there are. That is a solution of each equation in the system. So that's basically where the lines cross. So to solve some systems of equations, you will graph the equation and identify the points of intersection, so where they cross. Your solution is with the point in which it's true for each line. Okay, so let's do a few examples. So solve each system by graphing. Okay, you'll learn in Algebra 1 and Algebra 2 different ways to solve systems, but in pre-algebra we're just graphing. Okay, so if we're going to graph this first one, my y-intercept is 1, and my slope is -1. Remember, it's -1 over +1. So down 1 to the right 1, down 1 to the right 1. It's going to look like this, or up 1 to the left 1, up 1 to the left 1, like this. Okay, so we're going to draw a line. Whoops. We might need to extend it. We'll see where our other line is. Woo, it's a really crooked line. Okay, we'll see where our other line is. We might need to extend that. I'm going to change the color of mine just so we can see. Okay, our next one, y equals 2x plus 4. So now we're going to graph this on the same line, or on the same coordinate plane. So our y-intercept is 4 up here. And our slope is +2 over +1. Now if we go up 2 over 1, that's not going to help us any going up higher because we have to know where it crosses. So down 2 over 1, down 2 over 1. Okay, you still need to have at least 3 points on that line. Draw all the way through with arrows. Now, the solution is where they cross. So, right here. So that point is -1, +2. That is the solution. When it says solve each system, you just solved it, -1, 2. Now you will be graded on both graphs and if it intersected at the right spot and the answer. Make sure you write it as a coordinate, as a point. Okay, let's do the next one. Y equals 6x minus 6. So our y-intercept is -6. 1, 2, 3, 4. Of course, I don't have enough. -6. And our slope is 1 over 1. Okay, and it's positive, so it's going to be positive. Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. It's just going to keep going like this. Okay, depending on where the other graph is, you might have to do more, you might not have to do as many. Okay, so now let's graph this. So what is my y-intercept? Well, this is the same as +0, so we start there in the middle, and our slope is -2. Okay, so again, we go down 2 to the right 1, because this is really -2 over 1. Doing it this way is not wrong, but it's just not going to help us because it's not going to cross this line. So then down 2 over 1, down 2 over 1, like this. The line goes through. Okay, it crosses nice and neat right here, even though my line's a little off. And this is at the point 2, 1, 2, 3, -4. So this brings back knowing how your coordinates are. Okay, this is how I expect it to look. Okay, Okay, next one. So sometimes you're still going to have to solve for y. It needs to be in the form y equals mx plus b. So we need to subtract x. So y equals negative x plus 1. So we're at plus 1. This is just like the first one, it looks like. And then our slope is down 1 to the right 1, down 1 to the right 1. Or up 1 to the left 1, up 1 to the left 1. Draw a line. Okay, so let's say this line here didn't cross till way over here. Then you would need to extend this line. It just depends on what you're graphing. So here our y-intercept is 3, 1, 2, 3. And we're going to go down 1 to the right 1 as well. Down 1 to the right 1. Down 1 to the right 1. Down. What do you guys notice about these lines? Are they ever going to touch? Okay, these are parallel. Okay, and we know they're parallel before we even graph because they have the same slope. If they have the same slope, they're going to be parallel, which means if they never cross, they have no solution. Okay, meaning they don't have any point in common because it's going to keep being parallel. They'll never cross, so that's no solution. You actually need to write no solution. Do not leave it blank. Okay. On this one, we are going to, oh, hold on, I gotta get my pen right. So on this one, we also have to solve for y. So we subtract x, subtract x. So negative 2y equals negative x plus 4. Divide everything by negative 2. So y equals, again, 1/2 x minus 2. Okay, because there's really a 1 in front of that x. All right, and it's positive because the negative divided by negative. And then we come over here, we subtract 2x. So we have negative 4y equals negative 2x plus 8. Divide everything by negative 4. Y equals, again, 1/2 x minus 2. So what do you notice here? What do you notice about these? Let's go ahead and graph it. So negative 2 is our y-intercept. Up 1, it's positive. Up 1 over 2, up 1 over 2, up 1 over 2. Oops, up. Whoops. Up 1 over 2. It should be that one, not that one right there. Okay, so then, notice how it erases the whole thing. Okay, so we draw this line. So what do you notice about these two? They're the same line, the exact same line. Okay, the other one, our y-intercept was different, but our slope was the same, so they're parallel. This is one line on top of the other line. If we were to graph the other one, we could put it right on top of it, up 1 over 2, up 1 over 2. Our line would be the same. So every point is a solution to both equations. Okay, so if they're the same line, it's infinite solutions. Infinite solutions, meaning it's forever, every point's the same. Infinite solutions. Okay, this is an I. Infinite solutions. Okay, so same line, infinite solutions. Those are kind of the special ones. Okay. I think, oh, I do have one more. Okay, so sometimes you have to come up with your own. Find two numbers with a sum of 6 and a difference of 4. So our two numbers are x and y. So our first equation, our sum is 6. So x plus y equals 6. And the difference is 4. So x minus y equals 4. Okay, so now you have to solve these. Okay, so subtract x, y equals negative x plus 6 over here. Okay, so let's just go ahead and graph that. 1, 2, 3, 4, 5, 6. And it's down 1. It's nice negative, so it's going to be going like this. Wow! Almost straight. Over here, we're going to subtract x. We have negative y equals negative x plus 4, but we still have this negative y here, this negative 1y. So if we divide everything by negative 1, we have y equals positive x minus 4. So, oops, where'd my pen go? There it is. So if we have negative 4, 1, 2, 3, 4, and we're up 1 over 1, up 1 over 1, all the way. Okay, so even if you can do this one in your head, it says you have to solve it by graphing. So yes, you have to solve it this way. Okay, so so again, where's my point? It's right here where they cross. So 1, 2, 3, 4, 5 would be your x, and 1 would be your y. So x equals 5, y equals 1. Okay, the sum is 6, the difference is 4. Yes, you could have done that, but if they were harder, it helps to be able to graph them and see where they cross.